Good morning to all. So it's a long time. So due to your quarterly examination, so we did not meet through online class. So we are busy with preparations. Hope you all did well your examination. You are satisfied with your presentation. I hope everything went positive. And now in this class, so already we started the unit number 4, electricity. So the first part is over. So what is electricity? So what are the important points in electricity? We discussed in last class. So in today's class, we'll continue from the previous one. So first we'll start from this symbol used. Children, you see here what is the symbol of this? Then this one, this one, this one, this. Do you remember this? I know you all very well. You know very well. So what are the symbols which is given? Resistor, rheostat, ammeter, galvanometer, voltmeter, then LED, ground connection, then diode, standard diode, everything is given here. Everything is given as symbol used. So just to recall only, I showed this symbol used as at first in our class. Understood? These symbols we are using in circuit diagrams. If we are drawing the circuit with the help of the symbols means it is very easy to understand. This is circuit diagram, so it is easy way to understand, so that we are using the symbols, okay, in circuit diagram. So why I am saying this? So already we discussed about this in previous class, but I am recalling this because we have some reason. So why I recalled this is, and today's the starting of our topic is electrical components. So in last class we finished up to here. The convention of direction of flow of current will be taken always depends on direction of the electron. It means, what is the direction of electron? Opposite to the direction will be taken as direction of electric current. That is the convention of direction of electron. Okay, and here electrical components. So in starting of this class I said now some symbols are given. That symbols we are using like electric bulb, switch, or key, and rheostat, resistance, ammeter, voltmeter, galvanometer, etc., etc. So these components we are using, that is called as electrical components. That parts are called as electrical components, and these electrical components we are using to construct the electrical circuit. For what we are using? To construct the electrical circuit we are using these components. Okay, this is called as electrical components. And following that we are going to discuss about electric potential and potential difference. So here, for before explaining about the electric potential, we can discuss about the flow of water. When we are opening the tap, where the tap is connected through hose with the tank, water filled tank. Now when we are opening the tap, the water will comes through the tap easily from top to down. For this no electricity is required. Like this, how the water is coming easily from top to bottom without help of any external electricity or external energy, because of potential difference, because of pressure difference. So like this pressure difference, the electrons are flowing through the conductor from one point to another one point because of potential difference. Okay, the water is coming from top to bottom, this is because of pressure difference. Like that, there is a potential difference that is happening in conductor when the electrons are flowing. When the electrons will flow between the two ends of the conductor when we are maintaining with the high potential difference. Otherwise the electrons cannot flow. So where the electrons are producing? The electrons are produced from low potential. And where it is flowing? It is moving to high potential. That high potential is attracting the electrons. The direction of the electron is always opposite to the direction of electric current. The electric current direction is taken from positive to negative. The electrons flow will be taken as negative to positive. So similarly, we can explain the movement of the electrons with the help of this electric potential. Okay, and here there is a definition of electric potential. The electric potential is defined as we are giving some work done. We are doing some work. For what? To move a unit positive charge from where to where? From infinite to that particular point against electric force. என்ன பண்ணுறோம், ஒரு ஒர்க் கொடுக்குறோம். எதுக்கு கொடுக்குறோம்? யூனிட் பாசிட்டிவ் சார்ஜுக்கு நம்ம ஒர்க் கொடுக்குறோம். எதுக்கு இந்த ஒர்க் கொடுக்குறோன்னா, அந்த யூனிட் பாசிட்டிவ் சார்ஜை இன்ஃபைனைட் டிஸ்டன்ஸ்லேருந்து ஒரு பர்டிகுலர் பாயிண்ட் மூவ் பண்ணுறதுக்கு வேண்டி எப்படி கொடுக்குறோன்னா, against the electric force. This work done is called as electric potential. This work done is what is called as the electric potential. Okay, in the answer you can take for 2 mark question, define electric potential. Okay, please children, you can mark in your book using pencil use பண்ணி mark பண்ணிக்கங்க. So have you understood? Yes. And next is electric potential difference. In the electric potential difference oda definition like a electric potential. But என்ன சேஞ்ச் அப்படின்னா, எலக்ட்ரிக் பொட்டன்ஷியலில் பார்த்தோன்னா இன்ஃபைனைட்ல இருந்து நம்ம ஒரு பாயிண்ட்டுக்கு மூவ் பண்ணுவோம். கரெக்டாக? தட் இஸ் கால்ட் அஸ் எலக்ட்ரிக் பொட்டன்ஷியல். எதை? யூனிட் பாசிட்டிவ் சார்ஜை. இங்கே சேம் அதே தான். ஸோ த அமௌண்ட் ஆஃப் ஒர்க் டன் பிட்வீன் த 2 பாயிண்ட்ஸ். எந்த 2 பாயிண்ட்ஸ் அப்படின்னா, த யூனிட் இந்த அமௌண்ட் ஆஃப் ஒர்க் டன் எது கொடுக்குறோம்? ஃபார் யூனிட் பாசிட்டிவ் சார்ஜ். அதை மூவ் பண்ண போகிறோம். மூவ் பண்ணிட்டா தட் இஸ் கால்ட் அஸ் ஒர்க் டன். எங்கேருந்து எங்கே அப்படின்னா, ஒரு பாயிண்ட்லேருந்து இன்னொரு பாயிண்ட்டுக்கு. அங்கே என்ன சொன்னோம்? பொட்டன்ஷியலில் இன்ஃபைனைட் டு இன்ஃபைனைட்னா வி டோன்ட் நோ வேர் இட் இஸ் ஆர் இட் இஸ் மோர் ஹையர். பட் இதில் பார்த்தோன்னா ஒரு பாயிண்ட்லேருந்து இன்னொரு பாயிண்ட் நம்ம மூவ் பண்ணுறதுக்கு வாட் ஒர்க் டன் வி ஆர் கிவிங் against the electric force, this is called as electric potential difference. What is this? This is called as electric potential difference. Very good. Okay, so in the answering you can mark for 2 mark question, define electric potential difference. Okay, electric potential வேற, இது வேற, ரெண்டும் ஆல்மோஸ்ட் சேமாக தான் இருக்கும். அதை இன்ஃபைனைட்டை வச்சு நம்ம எக்ஸ்பிளைன் பண்ணுவோம். இந்த எலக்ட்ரிக் பொட்டன்ஷியல் டிஃப்ரென்ஸை பார்த்தோன்னா நம்ம ஒரு பாயிண்ட்டு இன்னொரு பாயிண்ட்டை நம்ம எக்ஸ்பிளைன் பண்ணுவோம். ஓகே, and there is a figure representation for this electric potential difference. Children, you see this figure 4.3. 2 points are given. கொடுத்துருக்கானா? So what are the points? A and B. At A we having the charge Q. At A என்ன இருக்கு? Q value இருக்கு, சார்ஜ் ஒன்று நம்ம வச்சிருக்கோம். ஓகே, and B is placed in some distance from A. சரியா? and A and B in betweenல என்ன பொட்டன்ஷியல் டிஃப்ரென்ஸ் தருன்றதை நம்ம ஃபார்முலா வச்சு இப்போ படிக்க போகிறோம். ஸோ ஃபார்முலா ஃபார் பொட்டன்ஷியல் டிஃப்ரென்ஸ் இஸ் the ratio between work done given and the unit positive charge for moving from one point to another one point to the charge. The ratio between work done to the charge. This is the formula for what? Potential difference. Are you clear, children? Yes. And next, say at the point A la ஒரு சார்ஜ் இருக்கு. அந்த சார்ஜ் எவ்வளோ பொட்டன்ஷியல் தருதுன்னா VA பொட்டன்ஷியல் தருது. B சார்ஜ் எவ்வளோ பொட்டன்ஷியல் இருக்குன்னா VB பொட்டன்ஷியல் கொடுக்குது. ஸோ at A we having the potential VA, at B we having the potential VB. சரியா? at the point A and B respectively, the potential difference between A and B we can write with the formula. எப்படி எழுதலாம் அப்படின்னா, V is equal to VA minus VB when VA is more அப்படின்றப்போ. சரியா? or else we can write the same formula as VB minus VA in another one expression. எப்போ இப்படி எழுதுவோம் அப்படின்னா, VB is more than VA. So this is the formula, is clearly indicating the potential difference between these 2 points. I understood, students? Yes, this is for electric potential difference. Okay, next is volt. Volt என்றது எதுக்கு யூஸ் பண்ணுறோன்னா, this is unit for electric potential or potential difference. This is a unit for what? Electric potential and potential difference. அது என்ன சிம்பிள் நம்ம இண்டிகேட் பண்ணுவோம் அப்படின்னா, the letter V we are using for volt. V is the symbol for volt. ஸோ ஒரு வோல்ட் நம்ம எப்படி டிஃபைன் பண்ணுவோம்? or the potential difference between the 2 points is 1 volt எப்போ இருக்கும் அப்படின்னா we are using the same formula. ஸோ அந்த 4.2 ஃபார்முலா பாருங்கள், ஒர்க் டனோட யூனிட் என்னது ஜூல், அதை நம்ம யூனிட் வேல்யூ எடுத்துக்குவோம். சார்ஜ் யூனிட் என்னது கூலும், குட், அதையும் நம்ம யூனிட் வேல்யூ எடுத்துக்குவோம். ஸோ இதே ஈக்குவேஷனை we are writing as like this. ஸோ 1 volt பொட்டன்ஷியல் யூனிட் என்னது வோல்ட், அதையும் நம்ம 1 வோல்ட்டாக மாற்றிடுறோம். ஸோ 1 volt is equal to the ratio between 1 joule to 1 coulomb. Okay, now there is a definition for volt. 1 volt is defined as if 1 joule of work is done in moving 1 coulomb of charge. Okay, inga 1 coulomb of charge from one point to another point. Don't forget to write against the electric force. Electric force towards side illa, it is happening against the electric force. Puriyudha, this is important point. This is the definition of volt. Then for answer for volt, you can mark from here up to here. This is the what? This is the definition of volt. So volt into another, it is nothing but unit for electric potential and electric potential difference. Or unit da volt ram eduthirukka difference da kuduthirukka. Okay, then after discussing about electric potential difference and figure representation and how to write the formula, இதெல்லாம் பார்த்துட்டு இப்போ நம்ம next volt define பண்ணிட்டோம். Voltage define பண்ணிட்டு then we are entering into the solved problem, and solved problem 2 is given, and this is a simple sum. And listen the question. The work done in moving a charge of 10 coulomb across 2 points in a circuit is 100 joule. Okay, then what is the potential difference between the points? This is question. What is the potential difference between the points? This is the question. And there is a solution. Charge kuduthirukka 10C, work done kuduthirukka in joule, that is 100 joule. Then potential difference is W by Q. This is the formula just we discussed. So W value is 100 and Q value is 10. 100 by 10 is equal to 10 voltage. It's a simple derivation. So the potential difference value for this question is 10 volt. Okay, and next topic is Ohm's law. This is important statement and very famous statement in this electricity. This Ohm's law explaining about the resistance very clearly. And this Ohm's law was given by German physicist George Simon Ohm. He established the relation between V and I. Okay, he established the relation between V, I. So சமீப recent adsலாம் நீங்கள் பார்த்துருப்பீங்க, கிரிக்கெட் மேட்ச் இன் பிட்வீனும் சரி, சீரியல்ஸ் இன் பிட்வீனும் சரி, ஃபில்ம் டிவியில் பார்க்குற ப்ரோக்ராம்ஸ் எல்லாத்துலேயுமே வின்னு ஒரு ஆட் கொடுத்துட்டே இருக்கான். டு யூ ரிமெம்பர்? வோடஃபோன் ஐடியா மர்ஜ் தான் வின்னு கொடுத்துருக்கான். அதை நீ மைண்டில் வச்சுக்கோ. ஸோ வி இஸ் நத்திங் பட் பொட்டன்ஷியல் டிஃப்ரென்ஸ், ஐ இஸ் வாட்? எலக்ட்ரிக் கரண்ட். ஸோ விக்கும் ஐக்கும் வின்னு சொல்கிற ஆடில் அதே மாதிரி மைண்டில் வச்சுக்கோ. விக்கும் ஐக்கும் என்ன ரிலேஷன்றதை எஸ்டாப்ளிஷ் பண்ணவர் வந்து ஓம். தட் ரூல், that establishment rule is called as Ohm's law. Understood? What is V? V is nothing but potential difference of a symbol, and I is nothing but a current. So this relation was established by the scientist Ohm. That law is called as Ohm's law. And here that activity will be understand from this activity. And see the figure 4.4. Check out that figure. Battery is given with the positive and negative symbol. Positive is connected with the ammeter. Ammeter is connected to the X. Y is connected with the rheostat. Between X and Y there is a resistor. And across X and Y we have the connection of voltmeter. And battery negative is connected with the key. And here is closed key. The bracket in between or dot vanda closed key. In the black dot illa appadina idu open key. Okay. And that key next is connected to rheostat. In this key there is no positive and negative. Both the sides is same. The circuit is given. And in the circuit which the Ohm's law explain பண்றாரு. ஸோ என்ன சொல்கிறார் அப்படின்னா, இந்த சர்க்கியூட்டில் ஃப்ளோ ஆகிற கரண்ட் பார்த்தோம்னா இஸ் ஆல்வேஸ் டைரக்ட்லி ப்ரொபோர்ஷனல் டு த பொட்டன்ஷியல் டிஃப்ரென்ஸ் V. ஸோ வாட் ஹி இஸ் சேயிங், V இஸ் ப்ரொபோர்ஷனல் டு I அப்படின்றாரு. என்ன மீனிங்? வாட் இஸ் மீனிங் ஆஃப் ப்ரொபோர்ஷனல்? நம்ம 9th நான் சொல்லியிருப்பேன், ஒரு சில டாப்பிக்கில் சொல்லியிருப்பேன்னு நினைக்கிறேன். ஒன்ஸ் ஐ வில் பி ரீகால். டைரக்ட்லி ப்ரொப்போர்ஷன் அப்படின்னா இந்த டேர்ம் இன்க்ரீஸ் ஆச்சுன்னா இதோட வேல்யூ இன்க்ரீஸ் ஆகும், இது டிக்ரீஸ் ஆச்சுன்னா இதுவும் டிக்ரீஸ் ஆகும். இட் மீன்ஸ் when potential difference increases, current increases. Potential difference decreases, current decreases. This is called as Ohm's rule. பட் இதில் ஒரு கண்டிஷன் இருக்குது. என்ன கண்டிஷன் அப்படின்னா this whole law, this experiment should be done with the same temperature. நம்ம எங்கே எந்த கண்ட்ரியில் பண்ணாலும் ஒரு பர்டிகுலர் டெம்பரேச்சரில் தான் இதை ஒபே ஆகும். இஃப் டெம்பரேச்சர் வேரி, த ரூம் டெம்பரேச்சர் வேரி, த சரௌண்டிங் டெம்பரேச்சர் வேரி அப்படின்றப்போ this law also will be affected from place to place. அப்போது when we are starting to give answer for this Ohm's law, we have to mention at first at a constant temperature. At a constant temperature, the potential difference between the two ends of the conductor is directly proportional to current flowing through that conductor. So potential difference அங்கே increase ஆச்சுன்னா current increase ஆகும், potential difference decrease ஆச்சுன்னா current to decrease ஆகும். Okay, so we got the equation V is proportional to I, or we can say I proportional to V from this. And இப்போ V நம்ம leftல அனுப்பிட்டோம்னா to remove the proportionality we are using the term constant. So constant use பண்ணுறதுக்கு we are using the term is resistance that we are using here. 1 by R is used as here constant. Then the same equation can be written here as இங்கே proportional பதிலாக நம்ம equal to போடணும்னா we have to use constant. Here the constant we are using, then this equation will become as I is equal to 1 by R into V, or we can write the same equation, R will goes left hand side, then it will become V is equal to I into R. So what is the equation? V is equal to I into R. This is the equation which was the relation established by the scientist Ohm. So this rule is called as Ohm's law. So Ohm's law ன்றது என்ன அப்படின்னா at constant temperature potential difference between the two ends of the conductor is directly proportional to electric current flowing through that conductor. This statement is called as Ohm's law. And see this equation, V is equal to IR. So V is potential difference, I is electric current that we know very well. I is electric current. Then what is R? Here R is constant. R is nothing but a resistance. Okay, so say if you are using any material, for example nichrome or copper or silver, anything, if you are using any material, for that particular material the resistance is constant. It is the meaning here. The resistance is constant when V is proportional to electric current. The condition is at constant temperature. When V is proportional to electric current means we can draw the diagram between V and I as a straight line. That is given in next page. So how we are getting the curve? We are getting the curve as a straight line when V is taken along the x-axis, I is taken as along the y-axis, and we got the answer between V versus I as a straight line. It gives the relation between potential versus current. As per Ohm's law, potential is directly proportional to current means the curve which we are drawing on graph will become like a straight line when V is taken as x-axis, I is taken as y-axis. This was explained by the rule is called as Ohm's law. And next this is Ohm's law, and you mark answer for this Ohm's law. The statement for Ohm's law is from you can mark at a constant temperature up to here, then this equation, include this equation. So this statement plus this equation, 2 mark question, right question, define Ohm's law. Okay, and for today's homework you mark questions, define 1 volt and state Ohm's law. Only these 2 questions you take as today's homework. Study that, write the 2 questions in your homework page. After that you take photos and send to me through WhatsApp to my personal number. Okay, thank you children, and remaining topics we will discuss in next class. Bye children.